सो गाइस, आज हम लोग सीखने वाले हैं कि कैसे जिंक जिंक एसओसी हम लोग यूज करके कैसे पीएस प्रोसेसिंग सिस्टम कैसे बात कर सकता है विद पीएल सिस्टम, राइट। सो आज हम लोग राइट करने वाले हैं कुछ डेटा प्रोसेसर से पीएल की तरफ, राइट, विद द हेल्प ऑफ जीपीआई। सो आपको देर लेट नहीं करते हुए मैं आपको आगे ले जाना चाहता हूँ। कैसे हम लोग ऐसे काम करते हैं कि पीएस से पीएल कैसे बात कर सकता है, क्या चीज़ ऐसे है ना। तो मैं आपको स्क्रीन शेयर करता हूँ कि कैसे हम लोग करते हैं, सिस्टम डिजाइन कैसे करते हैं। ओके, ओके गाइज, जस्ट 1 मिनट। रिकॉर्ड हो रहा है वीडियो। ओके, सो फर्स्ट ऑफ ऑल हम लोग कुछ कोई ब्लॉग डिजाइन करेंगे। सो लेट मी क्रिएट ब्लॉग डिजाइन। ब्लॉग डिजाइन के नाम रख लेते हैं कुछ PS टू PL कम्युनिकेशन, PS2 PL कम्युनिकेशन कम्यून ओके, PS2 PL कम्युनिकेशन। सो जैसे ब्लॉग डिजाइन करेंगे तो आपके पास ऐसे विंडो खुल के आ जाएगी, ऐसे विंडो खुल के आ जाएगी और आप यहाँ से चूज कर सकते हैं कि आईपी, जो भी आईपी आपको रिक्वायर्ड हो आपके डिजाइन में। यहाँ पे मल्टीपल आई की आईपी प्रोवाइडेड है थ्रू द Xilinx। there are multiple IP which are provided from the Xilinx. So whatever IP you required, you can add from here, and also you can add your IP to this repository as well. Okay, guys. So for our application, we are adding Zynq processing system. Zynq processing system, which is hard IP inside the zybo Z board Zynq series, Zynq 7000 SoC series board. There is a hard IP that is called Zynq processing system. So we will click on this IP. Okay, we will click on this IP and we'll wait for some moment. Until IP is added, we'll wait here. It will take some time to add. Okay, finally IP has been added. Now, now here you can see run block automation. Run block automation, right? With the help of this run block automation button, Xilinx will automatically connect the required peripherals with it. Okay, if we connect if we run the block automation, you can see here, you can see here, make the interface external fixed IO DDR. That means uh, that means we are using the zybo board. It will connect the DDR ports and it will fix all the input output ports, right? So we will click OK, then it will automatically connect. We don't require to write a constant for the input output of all the peripherals like I2C, UART, DDR. We don't require. It will connect with the board pins. Okay, so here you can see DDR and our IO pins are fixed. Xilinx, this Vivado tool automatically detect which board we are using. Then it will connect all the corresponding pin with the hardware pins. Okay, so here you can see Max MXI GP0 port. This is the port through which processing system block for the processing system block can talk with the PL system, right? For the processor, this is the hard IP, and all the other outside block it say it says as a PL, as a memory devices. It will see as a memory devices, right? So with the help of MXI GP0 port, it will talk with the all the outside world devices through the XI interconnect. Okay. So guys, I'm connecting another IP that is called GPIO, right? XI GPIO. So we are connecting this IP. So as you can see here, you can configure this IP as well. So you can double click on it. So you know there are two ports in the XI. You can all inputs or all outputs we are using as output, right? We are writing some data to this button. Okay. So we are using only GPIO first pin. We are not enabling two pin. So here, so board you can see you can connect with the with LED 4 bits because we can see here the output. So we are connecting this GPIO port with the LED 4 bits. Okay, guys. So IP configuration is done. Okay, IP configuration is done. So GPIO width is 4 bit. Default output value 000. Okay. Okay, now you can click OK. So now again we are running run block automation so that it will connect all the required element with it. Okay, solve the all automation toward okay, you can select this. So this Vivado tool will automatically connect all the required peripherals with the XIGP0. As you can see here, it has been connected. Processing system reset. This is the processing system reset, and this is the with the help of XI interconnect. It will connect with the XIGP GPIO. Let's optimize routing. Okay, so okay, regenerate. Okay, now it is visible. So you can see here, guys, with the help of MXIGP0, this port is connected with the XI interconnect. Through the XI interconnect, it will talk with the XI GPIO, right? So what is the function of XI interconnect? Basically, this XI interconnect can connect multiple devices, multiple GPIO, multiple devices with the PS, right? So how you might be thinking how he can talk with the multiple devices on the same time. So because as I told you, processing system for the processor, Zynq processor, all the outside world is a memory map devices. So always processor write on the some address as you can see here. We say we connect right GPIO. So you can see here this GPIO address is certain from certain range. Offset address 41202 41220 FFF high address, right? So whenever the PS write or read from the this address between this address, then it is talking with this GPIO, right? If you want to add another GPIO, let's suppose if you want to add another GPIO for the dummy purpose, I am adding GPIO another GPIO, right? So let's connect this GPIO again. Okay, so let's connect another GPIO, but in actual design we will be connecting only one GPIO. Okay, so as you can see here, so this GPIO one is connected with the buttons 4 bit button, right? So as you can see here, this SXI is also connecting with the XI interconnect. But you can see here, all the GPIO have the unique address, right? XI GPIO, let me show you. So this name, yes. So XIGP0 address is 4120, XIGP1 address is 4121, right? Both GPIO, all the peripherals have the different addresses which is provided by the processor. So processor, whenever processor want to write or read from this range 41212 4121 FM, then it is talking with the XIGPIO1 port. Otherwise, it is talking with the XIGP0 port, GPIO 0 port, 0, XIGPIO 0, right? So, you can assume that the XI interconnect is working as a demultiplexer, right? Here is a XI interconnect. Here is a data is coming from the processor, right? And it is XI interconnect is comparing the address, with the Zynq. Whenever the address is matches, it will send or read the data from that device, that GPIO address. Okay, so we are deleting this for right now. We'll be adding. We'll be doing in another video. Okay, guys. So as you can see here, this is clock is provided by the Zynq processor itself. We are not connecting with the external clock. Okay, so we can configure inside the Zynq processor. I want to show something. Okay, so here you can see the block design. Whichever devices you want to enable, you just have to click on that devices, right? This is the processor system block. So you can see here the 32 bits GP0 port. So these are the general purpose input output. There are two, master port and the slave port, right? If processor want to talk with the processor, if the processor want to write the data, then it will talk with the MXIGP0 port. If the processor want to read the data, then it will talk with the MXI GP0. Uh, there are two dedicated GPIO ports. With the help of this port, processor talk with the peripheral devices. Okay, guys. So as I can, if I click on this, so here you are seeing that GP master XI interconnect enable the general purpose XI master interface 1, right? You can enable, if you enable this, you can see here another GPIO port will be enabled. There are two. If you click slave port, general process 32-bit XI slave interface. So enable the XI high performance slave interface. There are four high performance slave interface, right? Okay, guys. So right now we are enabling two XIGP 0 and XIGP1 interface. Okay. So here you can see 2XIGP0 port are enabled, right? So let me add another GPIO for the sake of right now. So let's take it as an input. We are taking the inputs from the button, right? So here we are just connecting with the four button four switch. Okay, okay, guys. So let me we are taking. So let me run block automation. Okay, run block automation. After run block automation, you can see here it is connected with the help of XI interconnect. It is connecting, right? It is connecting the devices. So this is the master for the write operation, and another GPIO is connected, that is MXI GP1 port. This is talking with these devices. Let me disable GP1 port. Let me disable the this ports. GP1 interface. Let me disable it. Slave interface. Here we are connecting. Okay, guys. So we are again running run block automation. Okay, here you can see with the help of this port, it will talk with these devices. Okay, guys. So I'm just deleting this both. We are connecting only one GPIO ports. Okay. So now it's time to validate the design. After validating, if everything's fine, we will save the design and will run. Okay, where we have four critical warning there, parameters. So we can just ignore it. Okay, might fail when entering negative DQSSQ. Okay, let's ignore it. Okay, not a big deal. So now we have to generate the output product, generate output product, and also we will generate the wrapper of this design, right? While generating the wrapper, it will create the Verilog file for all the beside Zynq processing system. This is the hard IP inside the Zynq SoC. Beside this block, all the block processing system resource, reset X interconnect and GPIO port. All the logic will be implemented in the PL. So for all the logic, there will be Verilog or VHDL file will be created. Okay, guys. So it is updating right now. Till then, we will wait. It is taking a little time. Till then, we will stop. Okay, we will stop. I'm sharing you my screen again. So we have created the wrapper file and we have set it as a top. Now we're running the run synthesis, implementation, and the generate bit step. So all the step we are running, we are going through all the step. Okay. So I'm running here. Running synthesis. Okay, guys. So we are running here. So we will wait till it's completed. So till we have to close this. Student. Students been closed. So we are waiting here, right? You can see the design progress. Once we are done, synthesis. We are on the implementation phase. Installation. Optimization is running and forcing till the bit string was created. So it's fine. Optimization phase. Let's see what is the problem. Device arm that is no longer set the cable. Let's see to school. causing the problem. This is causing the problem. So for this, we are just disabling the constraint file. Disable this file. Again, we are running this because it is reading the constraint from another project. So this is causing problem for us. Okay, guys. So today we will be using this code. This is the zybo from the Resilient. It has the Zynq SoC hard IP, right? Whichever we saw right now processing system, right? Inside this chip, there is a hard block of the Zynq processor, and all the other logic, extra interconnect processing system, receive, and GPIO all are implemented in the real logic. So we will be using this four LED. You can see there are four LED above these ways. So we are sending the data from the processor to this net, right? So whichever LED we want to glow, we can glow this LED, right? Let's just wait for a moment so that we can test the LED. So it's routing the design. So implementation is successful, completed now. Now write the generate list. This is the final step. Now this step generate the read file, binary file. Okay, else So registration is successfully generated, guys. So let me launch. Directly, I am exporting my hardware. So include video stream must check it out. We have launched SDK. So we are launching the SDK right now. So then we'll be accessing the memory map devices, that is in our case XIGPIO. Okay, guys. Because as well, it's so there is another application. It's just, just wait a minute, guys. I have to close this program first of all. That's right. Just hang. So close the terminals. Now when I am launching the SDK, that's the SDK. Must have launched successfully. There's no other eclipse as open right now. So guys, here you can say application software development kit has run now. So here we can write our software code. So PS2 Pro PL communication wrapper you can see. So this is the hardware description file where all the peripheral you can see. In this file you can see all the peripherals which are connected with the devices and their addresses, right? So guys, without making a delay, let me show you the exercise guide. This is the slave. This is the device actual address, base address, and this is the high address, right? Which is the exactly same on the VERILOG. Okay, guys. So right now we are developing an application, so you have to go to File, New, File, then you have to go to the New. Then you have to write here some application. So test LED, we can LED. Yes. Let's write this. So you can choose here the platform standalone free tools. Okay, for the right now using standalone, and you can see other pretest CPI wrapper hardware platform. So we are now the our platform is PS2PL wrapper is our platform, right? PS2PL communication wrapper hardware platform. Okay, so this is the processor you want to write. There are two processors. So now you have to go to the next. We are creating the MPD application. Okay. So your MPT application has been created. You can see here you have to go to the source and you have to right click on this and create the new file. You have to choose the project. Right. So name LED test.c. LED test.c. Now I have to next. Next. Finish this. Say source file. LED.c. Source file LED.c. LED.c. Okay. Excellent. So as you can see here, yes, the LED.c file is created, right? So what we have today is we have to add the templates file, right? So just wait a minute. Okay. Yes. So okay, we will say so. So we have to write. We have to include some parameters. We can directly if the processor want to talk with this VPIO, it has to talk with some address. So basic the address is as you can see here 120. Right, this is the address where we have to write the data set address. Right. So you can directly write set address here like there is a function called zil out. Right? Zil out 8, 16, and 32. There are Xilinx input output function. So in our case, we are taking it 8. Right? You can directly write this address, which we so here you can directly write. Right? So this function take two parameters. One is the address and another is the data. Let's suppose we are we're turning it all the LEDs are on. So 0F. Right? So writing this data, we can write print so for the input output, you have to add the function as and another function I have to include that is the per but good design practice is not directly assigned this address. Beside we will include some parameters. Include x parameters. Include these two files. So if you want to see the declaration, go to F3. You can see all the GPIO address which we have included right now. We can go. So definition for the driver GPIO. You can see here. So base address 4120. This is the base address which is defined. This is the driver which is holding this address. You can use instead of that directly using that address. You can choose it. Okay. Now you can go to led.c file and want to paste this. Okay, guys. So let's set these functions. Any fault is there. So what's the problem? Okay, Jill out is undefined here. Silence out the function is undefined here. Include as include Jill H here. Jill 60. Just look. Jill out. Jill out it. So I was writing wrong function. So guys, as you can see here, now if anything is wrong, then you can see here. So the x parameter you can write in a small capital, but the function is you have to write this function. You have to write this function, right? F3 Jill out 8 okay, pointer address and data. Okay, guys. Let's open declaration. You can see the declaration. Void Jill out 8 sign address and value. Local address. So as you can see, so we are going to test this LED. So first we need to connect the hardware. We need to connect hardware with testing. So this is the driver board. I'm going to program it. So guys, this is connected now. So I am going to program. Okay. So let me program. You have to go to the program FPGA. It's the hardware platform. Wait file. Okay, we are just programming the PL part. PL part is programmed now. We are going to program the PS part. Run configuration. Go to run configuration. Then you have to standalone applications. So here you can choose the hardware platform. Okay, so to just program FPGA. So I'm just open this. I have to go to the application. Go to this and you can test LED from PS. Test LED from PS.ELA. We have to select it. Now we have to just apply it till 100% completed. We have to just wait it. And so this is 100% completed. Okay. So here we have turned on all the LEDs. So if you can, as you can see here, we have turned on all the LED. We have write processor data to the PL GPI. Okay, guys. So I am again changing the data here. Let's suppose we are writing 5 1010, right? That means uh, we are writing 8. That is 1010, right? So guys, we have to just save it. We launch the system debugger. You can see here, we don't need to reprogram the FPGA. So you can see here 1010, right? Right here 5. Just put it, save the design. Okay. Yes, we have to relaunch the design. And you will see the result. So 0101, that is 5. Okay, guys. So if you want to write any other data, let's suppose we want to write some other data. Let's suppose we want to write any other data means if we want to turn on LSP 2-bit on. So we have to write 3 here. Save the design. Just you need to launch the design. Launch the design. And see here 0011. That's 3. Okay. So this is the completion of our design, guys. Later on, we'll be discussing, we'll be using another GPIO and which will be used for the switch. We will use switch to control this LED. Okay, guys. Whenever the switch is on, then LED